Good morning, students. In the topic semiconductor and electronics, in the analog part, next portion is diode applications. Diode has many applications. One of the applications I am going to discuss now is rectifier circuits. Diode used as a rectifier. Rectifier circuit converts alternating current to DC current. What is alternating current and direct current difference? In the case of alternating current, voltage changes with voltage and current. Both will change in direction and magnitudes as function of sign with the time. V equal instantaneous voltage V equal to V naught is the peak voltage or maximum voltage into sine omega t. T is the time, omega is equals to 2 pi f. F is the AC frequency. As the time changes, V value, instantaneous values keeps on changing between the plus and minus Z. V equal to plus or minus V naught and 0. 0 and plus or minus V naught. The voltage increases to maximum, this is V maximum, V naught or V maximum, and then decreases to 0 and increases to V maximum, here negative sign, minus V naught. Take it as a maximum, peak values, maximum or peak values they called. This is the AC voltage gradually increasing and decreasing. We have to convert into DC. What is the DC? In the case of the DC, voltage or current remains constant. You can take the graph between the time and current. If you take no, current should be constant. If you take the voltage instead of current, if you take voltage, voltage should be constant with the time. Time changes, but voltage should be constant. This is the case of the pure DC cases. So voltage or current value and direction should remain constant with time. That is a pure DC. Constant V and I naught. But in the case of AC, both voltage and current gradually increases and decreases the function of sine or cosine we can take. That is AC. And rectifier circuits convert this AC to DC. Pure DC is not possible exactly, but nearest to DC we can take. DC means current should travel in the same directions. Negative should not be there. Here the positive cycle is because the negative cycle means current electrons are traveling in the opposite direction. In the case of the AC, if you take the resistance connected to the AC power supply, this is AC, DC current direction should be required I, arrow mark we keep, but AC we should not put a arrow mark because the current goes one side and again reverses, again goes one side and reverses. Everywhere electrons oscillating to and fro executing simple harmonic motion. So we don't need to put the arrow mark for the current in the case of the AC circuits. So when current traveling one direction we call it as a plus, opposite direction means we call it as a minus. And diodes function as a rectifier is that it acts as a switch. Diode acts as a switch. If you take the battery connected to the bulb, if the switch is closed, current passes and bulb glows. When switch is opened, the bulb will not glow. So bulb glows only when the current is passing through it, means close the switch. Open switch, bulb does not glow. And diode functions as a switch. In forward bias means P-type metal of the diode is connected to the plus terminal, N-type connected to the minus terminal, or you can take both positive terminals also. Should be higher potential, this should be lower potential. For example, this is a 10 volts plus, this is a plus 5 volts, this is low potential than this, then current will travel from high potential to low potential. So generally we discuss here now plus minus only. P connected to the plus terminal and N connected to the minus terminal, diode is forward biased and current passes from plus to minus, means through diode. This arrow mark of the diode indicates this is a circuit symbol for the diode. Arrow mark indicates direction of conventional current that can flow when the diode is forward biased. This plus P to plus, N to minus is forward bias. Current passes. Current passes means if this is connected in place of this switch, we can replace that with the diodes now. Current passes through this I, same direction. And if the diode is reversed, or polarity of the battery is reversed, P connected to minus, N connected to plus, reverse connection you have taken. This is a P and N, this is a plus of the battery, minus connected, diode is reverse biased. Reverse bias diode does not connect. Infinite, the ideal diode infinite resistance is infinity for the ideal diode in the reverse bias. And ideal diode forward resistance is 0. But practical cases what we see, forward resistance will be in ohms, some few ohms, 100 ohms like that will be there. Reverse bias mega ohms or kilo ohms, more than kilo ohms will be there for reverse bias in the practical cases. But ideal cases, reverse current is 0 and forward current is maximum. Resistance is 0, resistance is infinity ideal cases. So just we think of ideal cases now. In the case of the reverse bias, neglect the minority carriers here. Minority carriers exist only at high temperatures. Imagine low temperature. So minority carrier current is not there. That is opposite to the majority carriers. We are discussing only majority carriers. So N type connected to the positive terminal. This is reverse bias. Reverse bias means current is 0 in the circuit and bulb will not glow. So diode acts as a switch and permits current only in forward bias. Do not permit current in reverse bias. That is the principle we are using in the half wave rectifier. So diode conducts only in one direction in forward bias. Next parts we are using in this rectifier circuit. In these rectifiers, two types of rectifiers. Other one is called a half wave rectifier, another one is called a full wave rectifier. Now we are discussing is half wave rectifier. In the case of the half wave rectifier, this is AC voltage changing with time, and V input, AC input. From here to here, this is called as a one AC cycle. In this case, electrons complete one simple harmonic motion oscillations, one oscillation, one time period also we can take. One AC cycle. In one AC cycle, we have half cycle positive, half cycle negative, means opposite direction of the electrons. Electron try to go forward and backwards. But we are talking the conventional current means that the motion is opposite that of the electrons. We are meant to say this is conventional current. Electron motion is opposite directions. So current one direction only electrons goes, other direction electrons are stopped. And here, in the case of the half wave rectifier, only half of this cycle. This only becomes DC, this one is not becoming good DC, that will be missing in this case. That is a half wave rectifier. Parts, one transformer will be there, which is step down transformer, and then one diode and one resistance called as the load resistance. Load resistance is the resistance we connecting across the output. This is equal to the electrical device you are using. If you are using this circuit for the charging of the mobile phone, mobile circuit, whatever the resistance is there of the battery, that resistance of the battery and this RL should match. If a battery are not using, means the current has to pass through this. If you are not using the output any device, then current has to pass through it. For that also we take the help of one resistance fixer, generally 10 kilo ohms, 1 kilo ohms to 10 kilo ohms resistance fixer as a load resistance. Load means any device, any electronic devices or electrical devices which absorb the electrical energy is called as the load resistance. And output here is supposed to get the DC. We'll check up how it getting. Step down transformer decreases the voltage. We can identify by seeing the diagram. Number of turns in the primary. This is a primary, and this is secondary. Secondary number of turns less than that of primary number of turns. It is a step down transformer. It is not compulsory, but generally we use mobile chargers or adapters used for the radios, TVs. Even in the TV also, all electronic devices work with the DC, not with the AC. So inside the TV, AC current is converted into DC, and further modifications are done according to the requirement. So here in all these cases, AC voltage what we are using the houses is 230 volts around, and at 50 hertz. You step it down, means voltage is decreased to required voltage 6 volts, 12 volts, 3 volts. Mobile phone voltage is, battery voltage is 3.8 volts. This will be required is 5 volts. It should not take very large voltage. So we are taking some step down transformer according to requirement. Frequency is in 50 and 50 hertz. In the transformer, frequency do not change. This is also AC we are taking, and then this AC input is passing through this diodes. At the diodes, and in AC what happens, polarities will change between the plus and minus. Alternately, for the AC current is a plus minus. Current is trying to go this side, and suddenly it changes minus, and this becomes plus. Current will be reverse directions. Alternately, plus minus changes as a function of sign. So here let us take first plus and minus. When it is plus minus, P to plus, diode is forward bias, the current is passing through this like this. This is the direction of current, and that passing through load resistance we call as the same current as a IL. So this current passes through this IL and complete circuit, closed circuit. Current requires a compulsory closed circuit. Current passes like this, plus N2 minus, P2 plus. So current is passing in this direction, one direction. Next what happens, this becomes minus, this terminal becomes equal to plus. P connected to minus, N connected to plus. Diode is reverse biased. In the case of the reverse bias, the current do not pass, means current will not be passing here. IL is 0, and again plus comes, again plus comes, again minus comes, means alternately only when plus is there the current is passing, otherwise current is not passing. So output current, if you take when this is a plus, current is passing, minus no current, plus again plus. This is one cycle, one pulse is obtained. So frequency is nothing but equal to AC frequency, that is equals to 50 hertz. One cycle, one pulse. This is called as a pulse, and no negative side, only one side is there. Current is passing only in one direction. Only in one direction, not reverse direction. So the frequency output is equals to frequency input. This also will get this is a DC only. DC pulses, frequency is 50 hertz. At 50 cycles only we will get. But we call it as a DC. Hertz frequency is there, means suppose should not call it as a DC actually. But we are not taking the negative. Negative is not there, means it is not a AC. But these are called as a ripples, small pulses. Pulse frequency we call is 50 hertz. But this is not a pure DC. DC, how this pure DC, voltage and current should be constant. But this I am taking it as IL place, load current. It's not necessary. We can take in output voltage also we can take. Output voltage, if you take this amplitude should be the same. If I take the current, amplitude is less, because I equal to V by RL. due to that reason that load resistance is more than 1 ohms, in that case the current magnitude will be less than that of the voltage magnitude. If I take this as output, then this amplitude I naught is less than that of the V naught. This one pulse gap is coming here. I have to remove this gap. To remove the gap, what we do is capacitor filters, inductor filters are used. You have to connect one capacitor here, see, parallel to the output. When you connect the capacitor, what happens? Whenever the current is not there in the output from this reverse bias diodes, then the capacitor charges and provides the current to the load resistance or output, we can say. That means charged capacitor and provide the current. Again charged, again provide the current. The result is this, like this you will get. It is only positive. You have only positive voltages, no negative voltages. Means it is a DC, but not pure DC, near DC you can take. So this in this case with the help of the capacitors, or even you can take inductors. Inductors must be used in series and capacitor is in the parallel. Inductor opposes the change of the current by inducing the back EMF. So this inductor also reduces these ripples. These are called as a ripples. Small waves are called as ripples, but only positive ripples. Means voltage slightly increases and decreases, but do not become reversed. So after using these filters with capacitor filters I mentioned, because generally we use capacitor in simple cases, inductor also sometimes used. Whatever, even if you inductor and capacitor also, filter cases will be coming like this. Nearly, this is a nearly DC. Nearly DC, not 100% DC. 100% DC means there should not be any variation. This is a case of half-wave rectifier. AC passing through the diode converted into DC, because current is passing only in one direction, we call it as a DC. Plus to minus current is passing. This is always positive terminal, this is always negative terminal. What about the efficiency? Efficiency of the this rectifier is nothing but equal to, efficiency of the rectifier is nothing but equal to output DC voltage by input AC voltage. So output DC, output DC and input AC voltage. That variation is nothing but equal to, this ratio is called as output, better called as output power. Power, that is DC, and input power, that is AC. This is called as a efficiency, but they don't ask in terms of this, they ask in terms of the numbers. Efficiency of the transformer is given by 0.406 into load resistance by RL plus RF. Load resistance is that value what we have taken. That can be a device resistance, any electrical device you connecting across the circuit, and RF is a diode forward resistance, that will be in ohms, few ohms will be there, and ideal diode if you are taken means RF is 0. For ideal diode RF is 0, for reverse bias resistance is infinity. In the reverse bias does not conduct, this is case of ideal diode of course. And if you want in percentage, into 100%, 40.6 into RL by RL plus RF. If RF is 0, ideal diode if you take RF equal to 0, this RL cancels. So what you get, the ideal diode is case none but equal to ideal diode. Efficiency of the half rectifier is RL is cancelled. So what you get here is 20.6% or 0.406. No units for the efficiency. Efficiency is always output by input. This is the case of half wave rectifiers. Next point we have to discuss is full wave rectifier. Students, next type of the rectifier is full wave rectifier. In this full wave rectifier, half complete AC cycle is converted into DC. This one complete AC cycle, one cycle AC is converted into DC. In half wave rectifier, only half cycle is converted. In full wave rectifier, full cycle is converted. In this, we have the step down transformer. These center lines, these two lines between the primary coil and secondary coil. These lines indicates the core, ferrite core, which is a softer and core, laminated core we use to reduce the eddy currents and to increase the magnetic flux linkage between the primary and secondary coils. So the symbol generally in the circuit diagrams, transformer symbol taken as X. Step down transformer means voltage is decreased from primary to secondary. 230 volts to we want 6 volts output. Here output we are taking is equals to 6 volts DC. Then it has a center tapping. Center tapping means from secondary turns equally divided into two parts. If you want 6 volts, you have to take 6 volts, 6 volts. Total will be 12 volts you will get from end to end. Center point actually like a neutral point. If this is plus 6 volts, this will be negative 6 volts. This is a plus means this is a negative. If this is a plus, this will be minus. And with respect to plus, this is a minus. This with respect to minus, this will be plus. Plus minus, this will be always neutral, 0. If this is minus, alternating current alternately changes plus minus. Minus, this becomes a plus. When this is minus, this will be plus. This is plus means this is minus. This is electrically neutral you will have. So this is taken as a neutral. And at the end points A and B, the polarities will change between the plus and minus. And two diodes are connected at the extreme ends in parallel, same direction, and joined here. And in the center tapping connection, these electric wires, straight lines what you are taking are nothing but equal to connecting wires of more thickness carries more current and less resistance. Here center tapping wire taken with a loop here. Loop indicates no connection to this wire, jumping. It is jumping over this wire, it is like this, no touching. And connected to these output terminals. Load resistance is RL, load current is IL. Output voltage is VO, we can take a load voltage is also called as VL. Its output is DC. 6 volts means here also you are supposed to get a 6 volts. If you use the capacitor, small variation comes here, and there is a small voltage drop across the forward diodes. How much the voltage drop is for the silicon? If you have taken this voltage across this VB, barrier potential voltage is 0.7 volts. If 6 volts means minus 0.7, you have to take 6 minus 0.7 is the output you have to get. Generally we are discussing ideal diode means there is no voltage drop, but otherwise you have to reduce the voltage by 0.7 volts for silicon and 0.3 volts for germanium. Next, this 6 volts 50 cycles AC frequency same for primary and secondary of the transformers. Next, at point A, this for the diode D1, for example this is a plus, and other end B, at point B terminal it is minus. So this D1 A is forward biased, plus to plus, and through N connected through the load resistance like this. So this is a minus, this is a plus, means this is supposed to be minus, behaves like. Then in that case the forward D1 is forward biased, D2 is, check up D2, this is a P connected to minus, D2 is reverse biased. So D1 is forward biased means then D2 will be reverse biased. One forward biased, other one will be reverse biased. Whenever the forward biased is there, current will pass like this and through the load resistance completing the circuits. So it is going in these directions when D1 is forward biased. And D2 is reverse biased. Next what happens is this becomes minus, this becomes equal to plus. With respect to the plus, this will be minus, this minus means plus, plus means minus, reverse. Previously we taken this as a plus, minus, plus, minus. So with respect to minus, this is a plus. This is always neutral, 0 we can take. Whenever this becomes minus, this becomes equal to plus. Minus means D1 is reverse biased, P2 minus reverse biased, D2 is forward biased. So second case what happens here is D1 is reverse biased and D2 is forward biased. One forward bias means other one will be reverse biased. In that case, current, this is forward biased, this is reverse biased. Current will pass through these diodes like this, here is no connection, passes like this. Through RL you check up output, current is in the same direction. Here also same direction. That means from here current is same direction, through the D2 connecting also current is same directions. That means current is in the same direction, that is supposed to be DC, not changing in the output. Checking the case in the graphs. This is the input AC. First when plus term you are taken, at this you are taking only at one end only. Either A you take or B you take. At A, point A we are taking inputs. Only one place you take. At this point, if this is a forward biased, current through the resistance is present because D1 is forward biased. So current passes here. We can take this V output or we can take it as I output or IL we can take. Outputs. You can take out as a V output also voltage. Forward biased, current passes through the output because of the D1 is forward biased. So current is because of the D1 or voltage output is also because of D1. Next what happened is this is reverse biased, D2 is forward biased. Then current passes through the same load resistance. We are talking about load resistance. Because of D2 current is same direction. So you will get this because of minus. This is to D2 and current is traveling the same direction. So becomes positive in the output. Again cycle is repeated. D1, D2, D1, D2 like that alternately changes. But it's not compulsory that this should be D1, D2, D1, D2. It can be first D1 can D2 can be forward biased. So it can be this can be D2, this can be D1 alternately must D2 D1 next D2 D1. D1 D2 D1 D2 or D2 D1 D2 D1 can be there possibility. Anyone can be positive and negative, that is not in our control. Suddenly when you switch on, alternately changes the polarities. But output is not again pure DC. This is a pure DC. Output voltage and current should remain constant in magnitude and direction, but not pure DC. Voltage increasing and decreasing. There is no negative, so it is supposed to be DC only. So it's called as the ripples. This is called as the DC ripples. DC pulses. Sorry, DC pulses. Pulses means voltage appearing for the small duration is called as a pulse. Small voltage is 0, increasing to maximum, decreasing to 0, increasing to maximum, decreasing to 0, but not negative. Means opposite direction is not there. But if you take that capacitor filters, output if you connect across this as a capacitor charges when current is passing, and when there is no voltage here 0, that means voltage trying to decrease from the input, the capacitor provide the current. Then capacitor provide the current, output appears as a ripple. It's called the DC ripples. DC ripples. Small waves are called as ripples. Small amplitude waves, but they are only DC current. This is called as a AC component present in the DC ripples. This is a pure DC. But what about the ripple frequency? Ripple frequency, DC ripple frequency is double to the input frequency. Input frequency is 50 Hertz, means this output frequency will be 2 times, because in one cycle you are getting the 2 positive cycles. So this 50 Hertz means this becomes equal to 100 Hertz. That is called the DC ripple frequency, but generally they will ask what is the output in output frequency AC, means you have to take it as double to the input. But a half wave rectifier, same frequency. Full wave rectifier, double frequency. Efficiency of the full wave rectifier is 2 times the efficiency of the half wave rectifier, because completing the complete one cycle converted into DC, and this efficiency is 2 times efficiency of half rectifier. Half rectifier efficiency already we know it before. 2 times you multiply, that result is 0.81 to RL by RL plus RF. In percentage into 100%. It will not be 100 into 100 you have to take in percentages. Efficiency will not be 100%, it is always less than 100%, there is loss of energy. Next is this load resistance by RL plus RF. Ideal case if you take means RF is 0, forward resistance 0, and this becomes equal to 81.2%. And full wave rectifier, one more is there. This is also available in the market. But in the market as a bridge rectifier, if you ask, no, they will give you that is a full wave rectifier. One piece is available for us. In that piece 4 diodes are used. These are D1, D2, okay, D2, D3, D4. This is also full wave rectifier. Input AC voltage you are giving output, and output is obtained is DC. In this 4 at a time, 2 will be forward biased, 2 will be reverse biased. In the previous case, 1 forward, 1 reverse biased. Here 2 forward, 2 reverse. Again output we have to take the help of the capacitors. And this can withstand to the reverse voltages. Reverse voltage, same voltage across the diode active, means diode should withstand to the reverse voltages. Reverse breakdown voltage should be always more than that 6 volts. What we are using there, 6 plus 6 in the reverse, in that full wave rectifier, 6 plus 6, 12 volts it has to withstand. But here we have the 2 diodes, the total voltage will be shared. This can withstand to the more reverse voltages than the previous cases. Here we are taking the D1 and D2 current. For example, this is a plus, this is a minus. Input AC we are taking. Plus connected like this. So output becomes equal to plus. And current passing through this should pass like this to the minus. This is a minus, plus. So current will be going plus to minus like this and passing like this. D1 is forward bias, means D2 is reverse bias. In the input side, one is forward means other is reverse biased. Same in the other cases. Passing through this, but this will not pass it. Next it becomes equal to minus, this becomes equal to plus. Minus means this D1 is reverse biased, D2 is forward biased. So current passes like this. Reverse current cases you would find minus, means actually it is passing through this plus side, going like this. Here output current will be in the same direction you have to get it. Passing like this. How to remember this circuit? Bridge rectifier circuit, they will ask you the options. You have to identify which is correct circuit diagram. Input side you have to take one plus, other a minus. Output you have to take both diode N, one side, PP other sides. NN side you will get the positive terminals, and PP side you will get the negative terminals. Same diagram may be asked in the different way. They may connect the battery in the middle or load in the middle. Either way we can change. This is connected to plus, this is connected to minus AC. Sorry, this is AC. AC in between you can connect it. So again one side plus, it become current passes in this way, like this. Instead of that they may give as before like this, and this load resistors may be kept here. Instead of keeping outside, they may put inside in the middle. So you have to be careful. Just don't remembering is one terminal, output side, output positive side you have to take the N both same side. Output negative side you must have the PP of the two sides, and input side, output side, your one is P, another one is N, PN. Here also output side we have one P and N, this side PN. This is a full wave rectifiers, 2 types. One is with the transformer. In the second case, step down transformer also is this. We can take the transformer here, no step down required place. Here we are taking the step down transformer, but here step down is not necessary. You can take directly So center tapping is not required. So we require step down transformer. Step down transformer, no center tapping. In the step down transformer, center tapping is not required if you are using the bridge rectifier. But in the case of the step down, these two diodes, if you are using the step down transformer plus center tapping. Next application of the diodes is light emitting diode. In short, we call it as a LED. This is like a ordinary diode only, PN junction diode, but the difference is that its energy gap is adjusted to so that it produces the particular frequency or wavelength of the light whenever the electrons recombine. Whenever the electrons are recombined with the holes at the junction, then the energy radiated out. In the case of the energy band diagram, if you have taken, this is a valence band and this is a conduction band. Holes are present in the valence band, electrons in the conduction band, already conducting. When electrons are jumping back to the valence bands, means recombining with the holes, means broken bonds, incomplete bonds are combined. How we are getting this is the p-type metal, this is n-type metal. N-type metal electrons are present, p-type metal holes are present. So electrons are passing from n-type to p-type, then they have to cross the barrier potential in between. So that means they are jumping from when they are free to form the bonds. Then that energy whatever is present required to break the bonds is equals to energy required to recombine. So during that process there is some loss of energy. Electrons are accelerated when they are jumping into the bonds and produce the radiation. The energy radiated out is equals to HF or Hc by lambda. And for the problem's purpose, we use the approximate formula. Energy of the radiation coming out or light coming out of this diode, which is made transparent, is 12400 by lambda in angstroms energy in the electron volts. You can convert it into joules by multiplying with the electron charge. So the circuit diagram, we take it like this. Diode symbol is, LED symbol is diode symbol like before, but arrow marks are kept on the top. These arrow marks can be drawn straight lines or like a curves because waves are coming out of energy, particular energy coming out. Light is coming out means that is a LED, light emitting diode. And one series resistance is required to protect the diode for the large currents. When the large currents are there, diode will damage easily. So LED compulsory should have the one series resistance to protect it from damages. And the LED lifetime is permanent and infinity. But the problem with this LED is it won't produce all possible wavelengths. Even if it is white light producing also, do not produce all possible wavelengths. Different colors depends on the different energy gap. More energy gap differences can be made with by adding the different impurities. With the different impurities, we can change the energy gap of the semiconductors. Impurity generally 4th group elements, 3rd group element and 5th group element together. They are mixed up to produce the different wavelengths. If all wavelengths are produced means WebGR you will get, but it will not contain all possible wavelengths, not continuous spectra you will get from the light of these LEDs. But this lifespan compared to other light bulbs, tube lights, electric filament bulbs, so that energy, most of the energy is wasted there, coming into heat also. But here it is not like that. There is very less energy is wasted as the heat efficiency is very high. Efficiency is very high, but the problem is that you will not have the all wavelengths. Other than that, it has a lifetime also infinity, practically, theoretically infinity, provided you keep the proper current, less current. This is a case of LED. This formula we used in the photoelectric effect also. Here in these 3 applications we are going to discuss for the semiconductors. Here also same formula we are going to use. Next is a photodiode. Photodiode is a reverse bias diode. It is also made transparent. It is reverse bias diode and made transparent and connected to the battery reverse bias along with the resistance. Previously also battery supply is there. Here also battery supply is required. And reverse bias is there means current is supposed to be 0 because in reverse bias current do not pass. But when the light falls on these diodes, again at the junction barrier, ions are present. In ions means complete bonds are there. Then that covalent bonds will break if sufficient energy is falling. To break, energy required is nothing but equal to energy gap as before. At the junction, when light falls, the electron holes are broken out. And p-type metal, what type of ions are present is, p-type metal we have the negative ions, n-type metal is the positive ions. So whenever these bonds break, you will get the hole and electrons. They will ask you the question which direction holes are moving, which direction electrons are moving. In this case, holes electron created, but electrons attract towards the positive side, holes attract towards the negative side. Means what? Ions you have to see, not a p-n type. P-n type do not attract, these ions attract. In the p-n side what we have is the positive ions. So these are positive ions. P side we have the negative ions. So hole electrons are created, electron will go towards the n side, hole will go to side, p side. Positive side only goes, negative side only goes. That this point is important for you. And current is produced here, and we are taking the series resistance here, or load resistance, and output is taken across the load resistance. Output is taken across the load resistance and current passes. This current depends on the intensity of the light. More intensity of the light, more intensity means more waves, more photons, more waves, more breaking of the bonds, more breaking of the bonds, more electrons, more current. And after reaching the particular number, current depends on this photons only. More photons, more current. That is reverse bias current is microamperes we generally take. And this current increases with the increase of intensity. X1, X2, X3 are the intensities. I1, I2, I3 are the saturation current. Current will be increasing depending on this biasing voltage, slightly changes, but afterwards biasing voltage will not control the current because current depends on the intensity only. So for given intensity, current is constant. That's called saturation current. I1, I2, I3, saturation current corresponding to the intensities X1, X2, X3. They will ask you the ratios in the diagrams, which one is more. X1 is less, current means less saturation, less intensity. X3 is the more intensity. X3 more than X2, more than X1, I3 more than I2, more than I1. Saturation currents. In microamperes we take, and this photodiode requires a battery and also series resistance. In the TV remote controls, what you have using in the remote control in your hand is a infrared LED IR, which are not visible to us. Infrared radiations of wavelengths more than the red light will be produced, which are not visible to us, but semiconductor which is present inside the TV receiver, what is present there is photodiode. This receives the infrared radiations. Infrared radiation do not produce a photoelectric effect in the metals, but they can break the bonds in the covalent bonds in the semiconductors, thereby producing the current. And what is the direction of current in the circuit diagram is reverse current passes, it is a reverse bias, N2 plus, this whole current, whole direction is nothing but equal to conventional current direction. We have to take a reverse current passes in the case of reverse biased diodes. Reverse current, minus side only current is passing in the minus side direction. So this whole current direction is the conventional current direction you have to take. Sorry, this only now means like this. Reverse current passes. This is direction of current. Reverse current. Next type of semiconductor, this photovoltaic cell. It is similar to the diode only, combinations. Same diode can also be used as a battery cell. Without a battery we can get the current. This is called as a photovoltaic cell. Photovoltaic cell is nothing but solar cells. No battery cell is required for this, no battery connection is required. It contains the two metals, P and N type materials, and this function is same as the photodiode functions. Only difference is there is no battery here, and we take one metal base. On this metal base, P type metal is formed. On that again N type metal is formed. N type material thickness is less compared to that of the P type material. Very thin layer is formed. On this N type material, thin wire connections are fixed at the surface to collect the electron charges, electrons or charges, current, and output is taken from here, and for metal base also output is taken across the load resistance. No battery connection is required. Whenever the photons fall on it, this N-type metal is almost transparent. Light passes through this and falls at the junction, PN junction. PN junction contains the only ions. These ions are completely covalent bonds. The bonds break. Then energy required E is equals to Hc by lambda. That energy again is equals to HF equal to Hc by lambda. That is the energy gap required to break the covalent bonds. This is nothing but equal to, energy related is also equal to 12400 by lambda in angstroms energy in the electron volts. It is actually 138 something 00 will get it approximately 12400 we can take. This is energy required for the photons to break the bonds here. Whenever the bonds are broken, what happens again? They will ask you what is the direction of conventional current, what is the direction of electron motion here. Whenever the bonds break, N side what you have is a positive ions, P side what you have is a negative ions formed. That is a barrier potential. So electrons attracted by this plus will go towards the N side only. Holes will go towards P side. So conventional current direction is because the positive charges means holes. Holes are behaving like a positive charge, electrons behave like a negative charge. So electrons go towards the N side, holes go towards the P side, and current is produced here. This is the direction of conventional current in the circuit. This one cell produces very low voltage actually. Potential difference across this can be obtained. But we take the multiple cells in series. When you take the multiple cells in series, EMF or voltage is increasing, added. But if you take the cells in parallel, the current increases. Cells in parallel increases the current. Cells in series increase the voltage. So some cells are taken in series, some cells are taken in parallel to increase both the voltage and current, so that output power will be large. And this photo cell circuit diagram is like a plus minus only, like battery cell you have to take, because they provide the DC current itself and take in a circle around. This is a photo cell circuit diagram, and emit light is falling into this. You have to take like this diagram. So connected across the series resistance called as the load resistance. Current is coming from plus to minus across the load resistance. Output is taken from load resistance. Because current is taken output, outside we take the negative in the graph directions. Similarly, this block diagram, P N connected across the load resistance, and photons are falling at the junction. At the junction, electron holes formed by breaking the bonds, covalent bonds, and direction of electron flow is towards the N side only. This is the electron flow is towards N side, and whole flow is towards the P side, positive type, plus to plus only, side only, minus to minus, and conventional current direction is from plus to minus whole current direction. Current direction they will ask you. In this the graph, in any solar cells backside, if you check a polar panels means combination of several cells is called as a solar panel, contains the several cells in series and parallel to increase the voltage and current. There are the two points will be there, terms are there. One is called as a VOC. VOC is called as a open circuit voltage. Open circuit voltage. Voltage output will be maximum when current is not passing through it, and that voltage is called as a VOC. When RL is infinity means just remove this connection. Whenever the voltage you measure here with a potentiometer, any voltmeter if you use that has some resistance draws the current. When you are drawing the current means some voltage will be reduced because you are measuring the terminal voltage, not EMF. This VOC is corresponding to electromotive force, we can say. Maximum voltage the cell can provide is called as open circuit voltage, that is VOC. Then in this case open circuit voltage, what is the current means, what is I equal to 0, IL is 0 in this case. Next is short circuit current. Short circuit current means the load resistance is removed and short circuit is taken. No resistance means current is maximum. It is called as the short circuit current. ISC is short circuit current. The short circuit current maximum current when the output voltage is 0, that is called as a short circuit current. Okay, but operating voltage is in between, we take in between at midpoint of this is called the Q factor, Q point between VOC and ISC. In between we take the working voltages and currents.